Hey guys, welcome back. So today we're working on this 8,000 watt dual fuel Champion generator. This one I found on Facebook Marketplace for $200. According to the seller, this is a 2022 model, and he was using it one night to power his house when the engine locked up. So yeah, that is not a good sign. I mean, if an engine locks up while running, usually it's a terminal problem. That said, I took a gamble on this, buying it for $200 because Champion has a 3-year warranty. And this machine, I actually bought back in March of 2023. So at that point, it was only a year and a half old and still under warranty. And even now, a year later, it's still under warranty. So, I called Champion, gave them the serial number and the date of manufacture, which is printed on the side of the machine. And they agreed it is covered under warranty, but they wanted the receipt. And of course, I don't have that. And I'm guessing the original owner didn't have it either, which is how I ended up with it. Anyway, I rolled this into the corner, and it's been there for about a year. I've been waiting for the right size engine to repower this, and well, that engine has not come along. But I do have a couple engines that might work. So what I'm thinking is, let's tear this one down, figure out what went wrong. If we're lucky, we can fix it. Otherwise, we'll look at plan B. So let me get this up on the lift and get going on this. Pretty nice feature that you can have a quick disconnect on the battery. It makes installing it a lot easier. Anyway, let's see what we have for oil, keeping in mind we're going downhill. And we are right to the full mark. Oil doesn't look too bad. So let's actually level the machine out. We'll check the oil again, but I don't suspect that low oil was the issue. And yeah, we're lower than we were, but it's still in the safe zone. So yeah, if it was low oil, it wasn't due to the feet being the way that they are, but that doesn't mean it wasn't run on a hill. Anyway, let's get the starter recoil off and try to rotate the engine. Well, it's a good sign that the fan is intact. That was another possibility. Sometimes these fans just fly apart, and without the fan blowing the cool air on the cylinder, it'll overheat and also lock up an engine. So let's just try to gently persuade it to rotate. Oh. It's tight, but it moved a little. Doesn't feel very good. And right now I'm applying a lot of force. But it can go backwards, so let's actually stop. I'm going to pull the spark plug. We'll get a little bit of penetrating oil down there, and then we'll work at this a bit more. The plug has a fair amount of carbon on it, so it was running pretty rich or potentially burning oil, but it is dry. Anyway, I'm going to put a cocktail down there of PB Blaster and WD-40. And then we'll try to rotate the engine again. So we'll start by going backwards again. And it's really tight right there, so we'll keep going backwards. And it's tight again. So I'm just going to work it a little bit. See if we can get past the tight spot. All right, that is a hard stop right there. So let's go back the other way. And yeah, it's a hard stop. So we can get about 3/4 of the way around, but that piston is getting hung up somewhere. So, you know, I don't want to force it. Potentially there's a stuck valve, although if a valve is stuck, likely it's broken. And I might hear the connecting rod rattling a little bit. It's hard to tell if that's what that is. So yeah, let's get the valve cover off, see if both the valves are moving. Okay, so that is an interesting rocker setup. I haven't seen a design like that before. Anyway, the push rods, they are in place, which is good. The intake looks like it's a little bit open. The exhaust is closed. Let's make sure it's not stuck. And nope, that valve opens fine. Let's check the intake. And that one is tight. So let me rotate the engine a bit, see if that closes, and then we'll just double check it again. Well, the good news is it does close. Valve's not stuck. So, yeah, no red flags up here. I mean, everything looks pretty clean, actually. So, let's rotate the engine a bit more, see if we can get through the tight spot, or maybe when we hit the tight spot, you know, we can take a peek down and see where the piston is in its travel and see if that gives us any clues. Yeah, so we can't rotate it forward, so let's try backwards. And it's pretty tight right there. But we are getting through it. And right there is a pretty hard stop. Very hard stop. So let's take a look at the piston, see where it is in its travel. Yeah, it looks like we're at the top of the travel on the piston. You can see it right there through the spark plug hole. And I also see what looks like a crack, potentially, and another line right above it. So I'm not sure what that's about. So I'm going to rotate the engine so the piston goes back down, and we'll get the bore scope in there, see if that tells us anything. All right, let's see if I'm imagining things or if that is really a crack. Definitely a crack. And surprisingly a hole in that piston. And I think if you look to the left, I can see an imprint of a valve. So it looks like the piston struck a valve really hard, and that cracked the piston, punched a hole in it, and most likely caused damage to the head and the cylinder. So yeah, this engine is likely done. And look at that. That's incredible. On the left side of your screen, that is a valve. It broke clean off and just fell into the cylinder. And that's what caused all that damage. So yeah, that is not a good thing because that valve likely caused damage to the head and the cylinder. So repairing this may not be feasible at this point. So yeah, there's no question. This engine has to come apart to have any chance of working again. Actually, before we start tearing this thing apart, let's take another look with the side camera. See if we can figure out which valve got dropped. Now, based on the size, I'm thinking it was the exhaust valve. So I'm going to rotate the camera in that direction, see if we can get a glimpse of the valve. And yeah, that gaping hole right there, that is where the exhaust valve should be. So that is very interesting. You know, what would cause that on a new machine? You know, this was only a year and a half old when this happened. You know, initially I was thinking user error, but now I'm thinking manufacturing defect. Anyway, let's start tearing this thing apart. You know, we need to get the oil out, the tank off, exhaust off, pretty much everything removed from the engine, and then we can get the engine opened up and get a better look at just how bad the damage is. So we're going to start by just removing the fuel tank. So we need to get the lines disconnected. Now this tank I did drain a year ago. The tank's in very good condition, unlike a lot of the older machines I get. I'm going to carefully disconnect this tank vent. You know, I don't want to cause any damage because I am going to reuse this as far as the frame and all the accessories go. I do have two other engines. They're not as powerful though, so we're going to be a little bit limited. You know, we're not going to get to the 8,000 watts, but depending upon which engine I use, we should be able to get close to 7,000 watts. Anyway, let's get these bolts out, get the tank out of the way. Well, the good news is this looks like just a standard Honda clone carburetor. So if we do end up putting a different engine on that is a Honda or a Honda clone, this should bolt right on. You know, the big difference here is that we have an input for fuel as well as propane. So yeah, let's get the fuel solenoid unplugged. We'll get this gas line unplugged. And the fuel line, yeah, we also need to disconnect that. And this right here is the fuel solenoid wire, which goes into this bunch of wires, which we need to unravel. And it should just be two bullet connectors, so we'll get those unplugged. And the carb should be free. Sometimes shocking it like that will help get it out, but not in this case. Well, let's try the last one, see if that's stuck. Interesting. All right, let's try the bigger impact. I'm pretty sure this is a mistake, 'cause this is a tiny bolt, but given the condition of the engine, I'm not too worried about it. Just get the wire unplugged here on the bottom. That is the wire that kills spark by grounding out the coil. And now the coil should be free. Now it's free. There we go. There are 4 head bolts holding the head onto the engine. There's 2 at the top, which are accessible, and then there's 2 down here. And with the rockers installed, we can't access them. So I think if we remove this retainer, we then should be able to slide these pins out and pull the rockers, and then we'll have the access we need. And I'm actually going to rotate the engine. It feels like there's a bit of tension on the rockers. So we'll take that tension off. The pins should slide out a lot easier. All right, so right now the tension is off the exhaust. That said, there's still tension. So I don't want to damage the pin, just in case. Well, I think we have the smoking gun on what happened to the exhaust valve. When I took the intake rocker off, the rotator cap fell off. And that's not uncommon. You do have to be careful. These help the valves rotate, and usually it sits on the top of the valve stem. In this case, there is no valve stem for it to sit on. The keepers, although they're still there, they don't look like they're holding the valve. So the valve actually was allowed to fall in maybe 1/4 of an inch, and that's why it made contact with the piston. The piston just started hammering it and broke it off. So if I take the rotator off on the intake, I think we're going to see the valve stem right underneath it. Yeah, you can see it right there. So that is the point of failure. The retainer cap with, oh God, I don't even want to touch it. It's going to come right out. It's not holding the valve. Look at that. So usually these keepers lock the valve in place. There's a little groove right there. There's a keeper on each side. And yeah, it's not grabbing the valve at all. So I'm thinking the keepers are the point of failure. Let's try this one. And no, there should be a little ridge on the inside of the keeper that is kind of the inverse of this groove right here. So that's what locks these keepers in place and holds the retainer in place, which holds the valve up from falling into the engine. So yeah, I guess it makes me wonder, is this the cause, or is this just a symptom of the damage that happened? I'm thinking that's the cause. And there's a better look at the Carnage. So that valve definitely got slammed around in there quite a bit. Now, I'm not seeing any big chunks or damage on the cylinder, so there is a possibility that the cylinder is still good. Let me just wipe the junk out there real quick. We'll rotate the engine now that the valve is out of there, and see if it rotates better. As far as the head goes, it's not great. There is a lot of damage right here. It looks like it nicked the intake valve a bit. And as far as this seat goes, I do see some evidence of damage, although it's not terrible. So potentially this head could be reused, if we had some new valves. But yeah, the damage there, it's really close to the seat. And, I suspect we might have a little seat damage as well on the exhaust valve. Anyway, let's clean this up a bit and rotate the engine. Yeah, even with that valve out of the engine, we're not rotating. You know, it's getting bound up. You can see that crack opening up, and the top of the piston is moving forward, but the bottom is kind of stuck in place. So yeah, you know, as bad as this is, the bore is in excellent condition. I still see a lot of crosshatch. I don't see any damage from what happened here. So, you know, if I could get a new piston and likely a new head, then I think this engine could be rebuilt. You know, the crankshaft is likely okay. The connecting rod, I guess, is to be determined. So yeah, let's keep going here. Let's get the power head off, and once that's done, we can open up the engine and assess the internals for damage. It's already loose. That is kind of odd. Surprised it wasn't leaking. So let's get this foot properly secured while we're here. And we'll do the same on the other side. The oil that came out looks pretty good. There is no trace of metallic, no shiny bits. So that's a good sign. You know, I would say the bottom end is likely still good on this engine. So this does strike me as a little bit odd. Usually there's a bolt on either side holding this cover on, and the rotor bolt goes through the center. You know, in this case, we somehow have a single bolt holding the cover on right where the rotor bolt should be. So I think I'm about to learn something here, because I have not seen this design before. Okay, and that actually makes sense. So those are the two bolts I usually see. So we'll get those off, then we'll have access to the rotor bolt. And of course, we need to remove everything that's attached here. So this is the AVR, the automatic voltage regulator. It's just this wire harness right here, and then two wires going to the brushes. So actually we can just take that out as one unit. And this jumper right here connects the neutral to the ground. So you can see there's a green wire with a yellow stripe connected to the white wire. So if you need to make the generator floating, you would just remove this jumper. And if you're going to wire this to your house, then it should be a floating neutral. Just going to get the handle out of the way. So I've got the engine block supported by that piece of wood right there. And the reason for that is because the only thing supporting this side are these feet here on the end housing. And once we remove this, the engine is free to flop over and could potentially damage that rotor. See if we're going to get lucky here. Nope, not budging. So we're going to need a puller to free this end housing from the ball bearing. I'm going to try to use a 3-jaw puller just to distribute the stress across 3 points. A 2-jaw puller will work as well, but you do have to be a little bit more careful. This aluminum breaks real easy. And you don't want to put the jaw where the brushes go. You know, that area is especially weak. So we'll apply a little bit of pressure, not much though. If it doesn't come out, you might have to resort to plan B, because if you put too much pressure on this, the end housing will break. And in this case, the bearing's coming out. Okay, the stator's free. Huh. Seems like everything on this machine is just really tight. You know, this should be about 30 foot-pounds, and this can remove up to 300 foot-pounds. So yeah, something doesn't add up here. There we go. I'm going to thread this bolt back in most of the way. We'll leave a bit of slop. And if you strike it with a sufficiently heavy hammer, you should be able to shock it off the tapered shaft. Now, given how just about every fastener has been on this machine, you know, I'm guessing this one's going to put up a fight. Let's find out. Hey, that was pretty easy. Got one. There is a lot more damage in here than I thought. You know, we do have pieces of what I assume are piston, or the piston skirt, and I also see the dipper for the oiling system. So this is supposed to be on the bottom of the connecting rod, you know, splashing oil around as the crankshaft rotates. So that is kind of disappointing. You know, I was thinking or hoping that the connecting rod might be good, but without a dipper, that is definitely not good. Anyway, we got some more chunks here, and we have, looks like a circlip, I would say, for the wrist pin. So yeah, although the block isn't in terrible shape, you know, the damage is more than I thought it was. You know, as far as the end cover goes, it's actually in pretty good shape. You know, we got the camshaft right here. Lobes look pretty good, as well as the compression release. The bearings feel really good, and the governor's intact. So yeah, the cover's good. You know, the block is still looking good, but we do have more damage than I thought here. I was going to say, let's rotate the engine, because to get the counterbalance out, the timing marks need to be lined up, or else we're not going to clear. And the piston wasn't moving last time we checked. But now that we have access to the bottom, maybe we can help it out. So yeah, let's try to rotate it. We'll get these timing marks lined up so we can get the counterbalancer out. And then at that point, we'll be free to get the cap off. I overshot the timing mark, but I think I got enough clearance to get this out. All right, and last but not least, the connecting rod bolt. So I actually need to go back down to get access. All right, I'm going to try to push this piston up one last time. I left the flywheel on because I'm not planning on removing the crankshaft. I'm going to leave it in there if I can. All right, flywheel needs to come off. I can't get that piston to the top, so we will remove the flywheel, pull out the crankshaft, and we can just kind of tap that piston down into the block. Huh. This should come right off. Yeah, the best I can tell, it was just over torqued and it distorted the cup. And now it just can't clear the threads. It's hard to tell why that was so tight. You know, the threads undamaged. So before we get this off, I actually have to remove the starter. And I'm fairly certain that ring gear is not going to clear unless that's out of the way. So we got two 10mm bolts right there. Then the starter should just pull back. And then we'll try to shock that off. The flywheel is really close to the block. Like I can't get a pry bar back there. So a screwdriver is going to have to do. After all that, still can't get it out. The piston really needs to be up so that I can clear. You know, right now if I try to remove it, the counterweights are just going to hit the connecting rod and there's nowhere to move it. So I think we're going to have to resort to brute force to get this piston out, unfortunately. Close. I think that bought us enough room to get the crank out. Ah. This took quite a bit longer to break this engine down than I kind of ever expected. Anyway, you can kind of see why. The piston, the skirt, is completely missing on this side. And we're blowing out over here, so there's really nothing holding that wrist pin. So that's where that Circlip came from. And of course, the missing piece of the skirt, at least part of it's right there. So, yeah, unfortunately, the piston is trash. Wrist pin is probably trash. Rings are trash. Connecting rod is trash because the dipper is broken. And, of course, the head and pretty much everything on it is trash. So let's take a look at the cylinder now that the piston's out. We'll also take a look at the crank, see if those are any good. Crankshaft looks pretty good. You know, the main journal, I don't see any damage. The ball bearing, nice and smooth. So I would say the crankshaft is good. And, you know, now that we can see down the full length of the cylinder, not really seeing anything too concerning. You know, there is a little blemish on the top, but it's nothing that can be felt. So I would say, you know, the block is probably good. The cover is good. And these parts here are good. But we do need a new connecting rod, a new wrist pin, new piston, and new rings for sure. And the head really should be replaced. A couple new valves, new keepers. So, yeah, is this rebuildable? It is. But I took a quick look at the pricing on the Champion website, and I think for all those parts, we're looking at $300, maybe $400, and that's even if they're available. You know, the head was out of stock. You know, I haven't looked up these parts yet, but I'm willing to bet that they're out of stock or have a long lead time. So regardless, even if they had the parts, the cost doesn't make sense, especially when I have other options. So let's take a look at one of those options. So I've loosely reassembled this machine, of course, minus the piston, the connecting rod, and the bad valve. So although I can't source parts for this now, I'm willing to bet I can in the future. You know, these engines are fairly new to the market. You know, the 420cc engines are kind of the more popular ones that have been out there for a while, and this one is 458 cc's. So, you know, I'm thinking if given a little bit of time, you know, parts will be more readily available for this. So for now, we will set it aside. I am going to put the engine number down in the description in case anyone wants to try to source some parts at a reasonable price. But for now, you know, I do have other engines. One of them is a Generac 420cc engine, which isn't here right now. That one could produce 7,000 watts, but it doesn't have electric start. And this, well, it has electric start. It actually has a good battery. So, I'm thinking instead we use this Honda. It is the right color. It has electric start. The only downside is that this can produce 6,500 watts, not what the old one could do, which was 8,000 watts. We're going to lose a little bit there. That said, though, there's really not anything indicating what the wattage should be on this machine, except for a little sticker on the side here. So that sticker can be modified or removed so that we don't mislead anyone. Anyway, there is a video on this machine, actually quite a few. This engine came from the NEC generator. It's a 3-part series. And I also did a video recently on this because it had the wrong bell housing. So I took the end cover off and actually put a Generac end housing on there. And now this Honda is clone compatible. So yeah, I say we get this up on the lift, we'll get it moved on over. And then I want to test fit the rotor and just make sure everything's going to work out. I'm going to start by getting the exhaust off, but before I can do that, I need to remove this cooling tin to get better access to those bolts. I think we're going to be okay. Goes on the shaft without issue. The fan has plenty of clearance. And we have the right thread bolt. So let's just snug this up a bit, make sure it goes all the way in. And yeah, I think we lucked out on this one. So let's get this engine off and put it on the other frame. So before we drop this on the Champion frame, there's a few things we need to do to prep it. And I guess first off, this is a low-speed solenoid which energizes and holds the throttle in the idle position. This generator doesn't use it, so I'm just going to get it out of the way. Also, this switch is not needed because the generator frame has one. So we'll get that out, plug the hole. The starter solenoid, I think, needs to be replaced. I'm going to have to double check what the other machine had. This one is positive switched, and I think the other one on the Champion is negative switched. So we can either swap the whole thing or potentially just the solenoid. And then finally, the carburetor. we're not going to use this one because this only runs on gasoline. And of course, the other machine is dual fuel. So we're going to try to use that carburetor if we can. And we also don't need this auto choke. So that can be pulled out. There's also a port here on the insulator that picks up engine vacuum. So we either need to plug that or swap out the insulator. And we're going to leave that a little bit loose right now because when we get the cooling tin back on, we need to actually pull this forward a bit to slip it in place. And once that's done, we'll torque everything down. I thought this switch just spun out. At least that's how I put it in. But it might have a detent that's preventing me from removing it now that it's in. So I might actually have to pull the whole blower housing to get that off. So, yeah, I guess we'll come back to that. Let's get the carb stuff out of the way. We can just remove a few bolts and take care of that problem. Actually, that insulator is already loose, so I'm just going to pull the whole thing off because this little port right here, it's needed for that vacuum choke, so we might as well keep the two together. So we use this insulator. It's brand new. Actually sent from a subscriber, Roger, as part of a maintenance kit, which also includes a new carburetor. So thank you, Roger, for that. So we'll leave it like this for now. Once this is on the machine, we'll put the dual fuel carb on and bolt everything down. As far as the starter solenoid goes, technically we can use what's on this machine already. We just need to cut and splice and rewire some stuff up in the control panel, and this should work just fine. That said, why bother? We have the correct part. It is plug and play, no cutting and splicing required. So let's unbolt this one and move it on over. I think it's just going to drop in without any modification. I guess worst case, we can remove the entire starter motor and just swap out the assemblies. but I'd rather not, because to remove this, you have to first remove the flywheel. So let's try the easy thing first and see where that gets us. And that should do it. We are plug and play at this point. So once this engine is dropped into the frame, we can hook up most of the wiring just by plugging these in. And that just leaves a few things over here. We have the wire for killing spark that has a counterpart on the control panel, so that'll plug right in. This is a charge coil behind the flywheel, which the Champion doesn't use or have. So we will leave that unplugged. And the only other thing I'm noticing is that this machine has the low oil switch wire and the low oil module mounted right there, which is usually where they are. And on the Champion, we have no low oil module. We just have the switch going up to the control panel. So likely the module is up there and we don't actually need this one. So I'm going to remove this real quick and then we'll drop this into the frame. Interesting. The Champion engine is wider than most Honda clones. So the distance between these two supports is about 9¼ inches. And the Honda GX390, the mounting point is 7¾ of an inch. So we're 1.5 inches away from where we need to be. So luckily there are some adjustments here. So let's start with this one. We'll move it over. See what that gets us. I think that'll get us halfway there. So likely we're going to have to adjust the other one as well. And one thing I haven't spoken about, but I have concern about, is the exhaust. The head on the Honda, it's different. The exhaust should bolt up to it, but the exhaust length might come into play because it attaches to the stator. And if the Honda head is a little bit thinner, then it's going to throw things off. But we'll deal with that when we get there. Yeah, that got us halfway there. So let's move that one over, and I think we'll be good. Yeah, I'm not sure if this is going to work. This engine has these accommodations right here. This is just for mounting a small external tank, which obviously we don't need because we're going to have a huge one right here. But the Champion didn't have that. And right now we're getting really close to this. You know, of course, we're not dropped onto the mounts yet. So I think when we drop on, this will also drop down. You know, we might actually clear. So let me work at that a bit, and hopefully we don't need to make any modifications here. I mean, we're in, and we do have clearance. Granted, not much. That is about 1/8 of an inch of clearance between here and the control panel. So, you know, we do have some more adjustment down here. These mounting spots I centered, but I think if we just move everything one notch to the left, you know, that's going to buy us quite a bit more space. So I'm going to make that adjustment, and then we can move on. And this one we need to drill just a little hole. This is more like a locating pin to keep this from twisting around. Yeah, that is much better. Plenty of clearance between the engine and the control panel. So I think we're in the clear as far as this goes. So I'm going to tighten the engine down, and then I want to get the power head installed. I'm not going to wire it yet. You know, I want to test fit the exhaust and see if we're going to have any issues there. Got a wrench on the flywheel nut holding the crank still, so this bolt gets tightened to 30 foot-pounds. Before we get the stator on, I'm just going to clean up these brushes. You know, I removed the spark plug so there's no compression fighting me. And one thing you want to be really careful of is where the wire connects to the slip ring. There's a connection like that on each side, so you don't want to hit that because you could break the wire off, and then the rotor is no good. So now's a good time to rotate the engine. The spark plug's still out, so there's no compression fighting me. And if the stator is installed properly, the engine should rotate freely. No binding, no scraping. And in this case, it rotates without issue. So the power head install is good. Well, the exhaust, it doesn't fit, and not in the way that I was worried about. I was concerned about the length. And in this case, I can't even get it onto the studs because the frame rail's in the way. So I think it's a combination of things. First off, these studs are longer on the Honda than the Champion. So if they were shorter, I might be able to pivot it in place past the rail. And the issue is compounded by the fact that I mounted the engine and the stator about 3/4 of an inch further or closer to this side rail. So I'm going to remove this nut and then try to pivot the whole thing just a little bit to clear the rail and see if I can get the exhaust on then. And with any luck, I can pivot it back in place. Huh. Still doesn't fit. Unfortunately, the Generac exhaust, it's not going to fit. The distance between the studs on this 458cc engine, it's a little bit wider than most Honda clones. It's so close that potentially, we could egg these holes out a bit and make this fit. I also have this exhaust. This is from a Generac. It has its own heat shielding, so I could use this as well. Bolts on fine to the end housing. The problem is the pipe is just a little bit too short. So if I wanted to use this, I'd either have to come up with a longer pipe or potentially a spacer. So yeah, I'm going to pause it. Got to look around, see what I have, and make a decision. So I'm just at the storage locker checking out my stash of exhaust systems, and I have two that would bolt on to a Honda GX390. Unfortunately, the pipe is actually an inch shorter than the one we already have on the machine, so these are not going to do anything for us. I guess the worst case, I could cut one of these flanges off and use that as the spacer. And then I realized I have a third one. It's actually attached to a Honda GX390, and unlike the others, this one doesn't need support from the stator. It actually has a bracket that bolts right to the crankcase cover. So this for sure would work on that Champion machine. I guess the only downside is that there is no heat shielding, so we'd have to come up with something for that. That said, I don't think we have to, because if you look right here, it looks like we have a couple spacers stacked in there. So yeah, let's get the fasteners out and see if those are in fact spacers. Well, there is a spacer, but it is kind of locked in place. So the only way to get that spacer off would be to chop this pipe, and that's not something I want to do. You know, this exhaust, I need it for that engine. And yeah, I guess to make matters worse, this bracket doesn't bolt on to the sump cover bolts. There's actually separate standoffs on this cover, which the other engine doesn't have. So, you know, we could use this for testing, but it's not going to be supported very well. So we do need to come up with a better solution. And I actually already located some spacers on eBay. You know, they'll be here in about a week. But for now, let's just use this exhaust so we can test. Yeah, bolted on there pretty well. And even though the bracket can't be secured, it is right up against the bell housing as well as the crankcase cover. And it actually locks it in there pretty well. So I don't think we're going to have too much stress for those studs to handle, at least not for testing. And I guess the only downside is that because it was so close, the protective cage for the stator fan was in the way. So I had to pull that off. And now that fan is exposed. So yeah, not a permanent solution, but for testing, it should be fine. So I say we move on. Let's get the mounts for the stator attached. We'll finish up the wiring and move on to fuel. And an important step here is to replace these zip ties I cut off. There's enough slack on both of these wires that it can get sucked in, and wrapped around the rotor. And when that happens, well, that's pretty much it for the generator. So a couple zip ties, cheap insurance. I know it doesn't look like it, but we are getting very close. We just need to get the starter recoil back on, this cooling tin, carburetor, plug in a few wires, and we are going to be ready for contact. So I think I'm going to try this carb as is. Likely we are going to need to clean it. Now, there's already a gasket on the back of the carb, so we'll take this one off. And one thing I am noticing is that the Champion engine, the studs are about 1/4 of an inch longer. So, we can bolt this on for now without the airbox, but we are going to have to circle back and deal with this, assuming everything else checks out. Likely we're just going to have to pull the studs from this machine and just swap them with the other. Last but not least, we have the wiring. So let's start with this white wire. This would send power up to the control panel so that when you hit start, it has something to send down to the starter solenoid. So with those two wires, we should be able to crank the engine if we connect the battery. So let's try that real quick. Beautiful. All right, we can now plug in the fuel solenoid. And that's about all I can connect for now. The low oil sensor has a bullet connector, and on the Champion, although these I thought were bullet connectors, they're not. So we're going to have to modify these wires to connect them. Same thing for the kill wire. So for now, if we need to shut the engine down, we're going to have to ground out, actually not that wire, that's the one that goes to the control panel, but there is another one up on top of the engine, which goes to the ignition coil. Actually, it's that one right there. So that's the one we need to ground out. So I say we feed it a bit of fuel, turn it over, and see what we get. Okay, we're full. Let's give it a try. Choke is on. Contact. Beautiful. Started right up. Carb had no issues running the engine. The engine sounded great, and most importantly, we're making power. According to the display, we were just over 240 volts, about 60 hertz, and there were 455 hours on the clock before the old engine let go. Anyway, I can't finish the exhaust until I get the spacers, but I think I can finish everything else. As far as the airbox goes, I thought I would have to swap the studs out, and I would if I used the original airbox. It is plastic and quite thick, but if I swap it to a metal one, this one is stronger. It's actually much thinner material, and I think it'll bolt on to those studs without any modification. So we'll get that done. We will finish up the wiring, likely get the tank back on, and at that point, we're just going to play the waiting game until we get the parts we need to swap out that exhaust. Before I get this airbox installed, I actually am going to pull the blower housing off real quick. I stole the kill wire from the Champion, which has the correct connector for this control panel. So we'll get that installed real quick and move on. So I realize it's just about impossible to show you this, but we now have the wire coming from the ignition coil, and this is the wire that goes up to the control panel. So when I connect these two together, we'll then be able to shut the engine down using the switch on the control panel. So that just leaves the oil sensor. And these wires, as they are pretty short. And I need to cut one of them back and put another connector on, in which case, I think they're going to be too short to connect. So I'm thinking I'm just going to cut this wire right here. We'll extend it a bit and then plug it in. Well, and that's pretty much it for now. There's not much more I can do. The wiring is complete. We've got everything secured. And thankfully, this airbox worked out. I wasn't looking forward to trying to pull the studs on either engine, and thankfully we didn't have to. So at this point, really the big outstanding item is the exhaust. But we can't do it until we get the spacer, and putting the tank on now also doesn't make sense because this tin has to be uninstalled to swap the exhaust systems. And with the tank in the way, that's just going to create an obstruction. So for now, I'm going to pause it. And when the part shows up, we'll finish it up. So the 1/4-inch spacer showed up today and looks to be exactly what we need. I also got a couple gaskets in case we need them. I think we're going to need at least one. So I've already removed the bolts from this top tin, so let's pop that off, remove this exhaust, and put that one in its place. So it looks like there is already a gasket on the engine side, so we can leave that as is. So we'll just add the spacer, and we do need a new gasket on the exhaust side. Yeah, it looks like that did it. So that 1/4-inch spacer, it gave us the extra reach that we needed. So now we're secured properly, both on the engine side as well as the stator side. And now this exhaust is nice and secure. So exhaust, we can cross off the list. We can get this tin reinstalled, as well as the shield for the rotor. And once that's done, I want to try running this on propane. This is a dual fuel generator, and we know it runs well on gasoline, but I guess the question is, does it run just as well on propane? So let's finish getting this back together and find out. to run this on propane, it's a pretty nice setup they have here. You know, this way is to run on gasoline, and the other way, propane. And when in this mode, it actually closes that valve, so you don't end up with a vacuum leak in the carburetor. Now, to feed the propane in, there is a quick connect right here. You know, that connects over to the propane tank. On the other side is a lock-off valve, which doesn't allow propane to flow unless you're cranking the engine or the engine's running. So that is there really as a safety device. Now, the line that runs to the tank, unfortunately, didn't come with this machine. Now, Champion does list it on their website, but it's not available. It actually hasn't been available that I've seen in the last year. So rather than waiting for that, I ended up picking up a few parts from other locations. The first one being this right here from US Carb. It is a propane line with a 200,000 BT regulator. So this will run up to a 20 horse engine, and this one's only 13, so that should be more than enough. Now, the other end, it is a 3/8 flare, which is not going to connect to here. So I picked up a quick connect, which is the proper one for this machine. Now, on the other end, though, it is a 3/8 NPT thread, and here we have a 3/8 flare. So to connect those up, we got the proper adapter. So, you know, I say we connect this up, plumb everything in, and try it out. So we'll start with the flare end. This one does not need any thread sealant, but the other side that has the NPT thread, that will need some propane rated sealant to prevent that one from leaking. So just turn the propane on, and I've already checked this for leaks. You know, looks like we're sealed tight on both ends. So we should be ready for contact. Now, it will be an extended crank because this line, it is full of air. So we got to get that purged out before the engine will start. All right, let's give this a try. The choke is off, and theoretically we shouldn't need it. The lock-off valve should be sensitive enough to allow the propane to flow. If it doesn't start after extended cranking, you know, I might close that choke. That'll build a higher vacuum, which will definitely be enough to trigger that valve. So let's give it a try. And unfortunately, there's no purge valve. A lot of times they do have that on the demand regulator. So cranking it is really the only way to get that valve to open. So I am going to close the choke. Let's try this again. Almost. Choke's off again. All right, let's try it one more time now that the air is purged. Choke is off. And yeah, it's kicking a little, but it doesn't like it with the choke off, so we will close it a bit. Almost. I don't know what it is, but propane generators, they're usually hard to start. And this one's no exception. There was an extended crank. You know, it did start popping a little bit, but it wouldn't take off at least not until I applied that choke. Once I did, the engine started without issue. I was able to turn the choke off right away, and things sounded pretty good. So on the surface, we are looking good, as far as running on gasoline and propane. I guess the real test is how will it do under load, and of course, what's the max load going to be? I'm thinking on gasoline, 6,500 to 7,000 watts. On propane, it's going to be less. We'll be, I think, lucky to reach 6,000. So let's get the tank bolted back in place, and then we'll bring this outside and see what it can do. All right, I think we're pretty much ready to go. I'm going to start with gasoline. That provides the most amount of horsepower, and that'll tell us the most this engine can do. So I'm going to get the engine started. We will let it warm up. While it's doing that, we will double check the output, both the volts and the hertz, as well as the power quality. And then we'll start to bring on the load. I'm going to bring it up to about 3,000 watts, then 6,000 watts, and then we will do it 500 watts at a time until we reach the max load that this engine can pull. I'm not sure what happened there. I was letting the engine warm up, and it just shut down, like someone turned it off. So either it's the low oil sensor, or maybe we have an ignition problem. So I'm pretty sure the spark plug that's in there is new, but let's just make sure. We'll swap that out. We'll get it started again, see if it's going to keep running. Actually, I'm going to bypass the oil switch. I remember on the NAC generator that this engine came from, we had a similar issue. I put a new oil module on, it's just out of sight. I put a new ignition coil on and a new spark plug in. And the fact that, the shutdown continues tells me that it's likely the oil switch. So we could unplug it right here. That still leaves the oil module in circuit. But I think that'll be a good test. That'll tell us for sure if it's the switch or not. So I'm going to restart it, and we'll just let it run for a bit, see how it does. Yeah, it's been running for 6 minutes without issue, so I'm going to plug that oil sensor back in while the engine's running and see what happens. So it's been running a total of 10 minutes now. 5 minutes with the oil sensor unplugged and 5 minutes with it plugged in. So I'm a little hesitant to put a load on because the load bank needs the power from the generator to cool. So if it stalls, I really need to restart it quickly to keep this cooling as it should. So I'm going to shut it down, probably just swap the spark plug out just to make sure, and then we'll try to put a load on it. Nope. Although it's a name brand, definitely not new. So BPR 6ES. Let me see if I have a new one of those. So I do have a new plug. It is a little bit cooler. It's a BPR 7ES. You know, ideally it should be the 6ES, but you know, to run it like this for a short time isn't a big deal, but I will have to order up the proper plug. So that was an immediate fail. So I'm going to unplug the oil switch again. So if it shuts down, there's only a few possibilities left. Either the low oil module, which is in the control panel, that's still in circuit, the ignition switch, or the coil itself, which I know is new, but you know, just because it's new doesn't mean it's good. So I'm going to restart it, and assuming it stays running, I think I'm going to proceed and put a load on. And if it does stall, I'm just going to have to restart it quickly just to help that load bank cool down. It's been a couple minutes with no load, and things are running fine. So let's turn this meter back on. We'll check the no load THD, which comes in at about 4%. Sine wave looks pretty typical for a generator like this. So I'm going to start with 3,000 watts. We'll give it a few minutes, and hopefully it stays running. So that's a 3,000 watt load. THD went up to 9.7%. And the sine wave doesn't look terrible, but I wouldn't say it looks great either. So we'll let this run for a bit, and hopefully it keeps going. It's been a few minutes, so I'm going to bring the load up slowly. I'm going to swap 1,000 for 4, or I should say 2, so the total is 4. Now we're at 5, 5,500, and the hertz, they are dropping. We're at about 56, actually a little higher, probably around 58 hertz. Now we're under a 6,000 watt load, and it's going to stall. So 6,000 watts it actually cannot do, which is a little disappointing. So I'm going to bring it back up to 5,500 watts. THD is at 12.6. The sine wave looks about the same. So I'm going to give this a few minutes, see if the engine can keep running. So no issue holding the 5,500 watts. I'm going to try 6,000 again now that it's warmed up a little more. Yeah, it's doing it, but I wouldn't say it's doing it with confidence. So, yeah, unfortunately, we're not hitting the 6,500 watts that I had wanted. We're falling pretty short. So I'm going to let the load bank cool down a bit, then we'll try it on propane. Okay, I've got the propane all plumbed in and ready to go. So, it'll be interesting to see how this does, because on gasoline, it did 5,500 watts with confidence. 6,000 was pretty shaky. So if 6,000 was the max on gasoline, then on propane, the max should be at around maybe 5,400 watts, somewhere between 5,000 and I'd say 5,500. Now, I do suspect that the carb that's on there may have been running rich, because, I actually filled the test tank quite a bit fuller than I normally do, and it just sucked down that fuel. So if it's running rich, then that would certainly explain why we're missing about 2 horsepower on this engine. This is rated at 13 horse, and 6,000 watts requires about 11 horsepower. So yeah, it'll be interesting. If this can also pull 6,000 watts on propane, then I would say likely the carb is to blame on why we kind of fell short running on gasoline. So let's get it started and see what we get. All right, it's been a few minutes running on propane at low load. So far, so good. So I'm not going to check the outputs this time. The power quality is going to remain unchanged. But what I am interested in is to find out kind of the max load. When running on propane, we should be down by about 10%. So 6,000 watts less 10%, 5,400 watts is about the best we can expect, unless there's a problem with the carburetor. So we'll start with 3,000 watts, handling it without issue. Let's swap that. We're now at 4,000 watts, 5,000 watts, 5,500. It's running well. How about 6,000? Yeah, it's doing it. Let's try 6,500. So we're back to 6,000. Nope, can't do 65. So 6,000 is the most it can do, which actually was what I was expecting running on propane. It's really the gasoline part that fell short. So I'm going to let this cool down. I'm going to take a look, see if I have another carb we can throw on there, and maybe we'll get a different result. All right, so I do have a brand new carburetor. Now, it is a clone, but the Honda clones usually run the engine pretty well. This one was actually sent to me by Spencer back in April of last year. So it'll be interesting to see if this makes a difference, because right now we're getting 6,000 watts max with propane or gasoline, which makes no sense. Propane should be down by at least 10%. So that tells me the carb running on gasoline is the problem. So let's swap out the carb. We will do a quick test, see if we can get above 6,000 watts. I forgot, actually, I can't use that other carb. Actually, I can't use any other carb if I want to run also on propane. So we have to stick with this carb. This is the original one that came on the Champion engine. But the Champion engine was a larger engine by about 70 cc's, I believe. So, possibly the jetting is off. So I will get this carb off. We'll compare the size of the main jet to the one that Spencer gave us. So yeah, this jet, it is pretty big. It fits on the largest micro drill bit, which is a size 61. And I'm pretty sure the stock kind of GX390 main jet is a little bit smaller. So let me pull the main jet out of that clone carb, see where it comes in at. Yeah, so the GX390 clone also fits on the number 61, but it's a much tighter fit. If I wobble it, you can see it barely moves. And if I take the one that came on the Champion and do the same, it moves quite a bit. So although we can't tell exactly how much bigger the Champion main jet is, it's definitely bigger. So I am going to use the clone jet, I think, for the GX390. And we'll try this again. All right, the rejetted carb has been reinstalled and we're plumbed back into gasoline. So I'm going to make this a quick test because my neighbors across the street, they're having a pool party. So I don't want to crash the party too bad, but I've got to know if that was the issue. So I'm going to restart it. After a short warm up, we will bring the load up to 6,000 watts. And then we're going to try for 6,500. And if it can do that, we'll try 7,000 because a 13 horse GX390 should be able to do 7,000 watts if it's running as it should. So let's get it started and see what we get. So it's definitely running a little bit lean with that jet in there. I had to give it partial choke to smooth it out. So I'm not really expecting a big difference here, but let's try. We'll bring it up to 6,000 watts. You can see the speed is a little unsteady. 4,000. Nope, it's even worse. Can't do 6,000 with that smaller jet in there. Yeah, I was really hoping that that smaller main jet would fix the issue. Instead, I think I made things worse because this time, without a load, the engine was surging. So I did have to apply partial choke to get things to smooth out. And then I tried to bring the load up to 6,000 watts. And as soon as we hit 6,000, the Hertz meter started to drop like a rock. So the engine was going to stall, had to take the load off to prevent that. So I think I need to put that original jet back in. It was doing a better job. Anyway, I was a little hesitant going into this project because the original engine that was on there was pretty powerful. It was rated for 8,000 watts, and I knew that this GX390 would not be able to do that. 7,000 watts would be the absolute best. 6,500 it should have done. And instead, we have a machine that'll do 6,000 watts on either fuel. So yeah, a little bit disappointing, but at the end of the day, this machine was about a year old when it blew up. It sat for another year collecting dust. And of course, in that condition, it produced no watts. So yeah, 6,000 is quite a bit better than nothing at all. So I hope this video helps someone. Thanks for watching.